Welcome to my YouTube channel Infinite Knowledge, and today we are talking about another project, and that is a final year project for electrical engineering of high voltage engineering, high voltage generation using voltage multiplier. So this is a basic project. The name of the project is high voltage DC generation using a Cockroft voltage multiplier circuit. So what is the basic of this project and what is the outline of presentation? I will cover in this video all the things, all the simulation, all the problem definition, introduction, advantages, block diagram, circuit diagram, output and result mathematical model, conclusion and reference, all the things that I cover in this presentation. If you want a circuit diagram, I have simulated in MATLAB as well as Proteus, so I will send both the simulation in description box, so you can get the simulation from description box. And if you want a PPT, this PPT and report, then I will share that two things also. So what is the problem definition? This project is based on voltage generation. It means this project is based on voltage multiplier. What it means by voltage multiplier? We multiply the voltage. First, if you applied a voltage, that is a Vm, and if you use a multiplier circuit, you get a output voltage is 2 Vm. It means double of the supply voltage. So if you use another multiplier circuit, so you get 4 Vm. So this is how this project work, and we can multiply the supply voltage for number of times using a multiplier or voltage doubler circuit. A voltage multiplier for high voltage DC generation. This project is to design a high voltage low power DC supply device that can produce high voltage up to 10 kV, in which in this project we have considered up to 10 kV. So if you want more, you can go up to a 50 kV, 100 kV, but according to that you have to use a different power electronics component that can withstand a high voltage with the lowest current and the power value. So this is a problem definition. Now what is the introduction of this project? Voltage multiplier is an electrical circuit that converts AC electrical power from a lower voltage to a higher DC voltage. So what is the intent of, or what we have done in this project? We have supplied the AC supply to the circuit, and that is a 230 volt AC supply that you get at your house. 230 volt 50 Hz supply given to the circuit, and that circuit generate up to a 1.7 kV DC voltage at the output side. We will see how this happen in the simulation or in the MATLAB simulation circuit. The voltage can be step up by using a ladder network. There are a number of ladder network. What is a ladder network? That we will understand soon. Ladle network by ladle of the diode and capacitor. Here we use only a diode and capacitor. There is no bigger transformer. So due to the multiplier can create high voltage from a low voltage source. It means we have not used any transformer. We use only a diode and capacitor, and not any inductor also. Only use of diode and capacitor, we get high voltage DC supply at the output side. So now what is the further need of multiplier? What is the need? What is the use of? What is the application of this project? Is use of laboratory practice in a high voltage laboratory, in which we have to require high voltage DC supply, HV supply. We can use this circuit now used for testing of the HV cables and capacitors that we made in the high voltage equipment, as a high voltage equipment, as a power system equipment. Use for the testing of breakdown capacity. What is a breakdown capacity? It means the puncture capacity of any equipment, of any dielectric material, of any insulating material. For the cathode ray tube and microwaves oven, high voltage DC photomultiplier tubes are used at nuclear industry for detecting the radiation. Also used for the for scientific instrument. So this is the application need of this project. Now we go to further. What is the advantage of this multiplier? No magnetic element. So there is no magnetically interference, because we did not use any inductor in this circuit. So there is no inductor, no magnetic field, no magnetic interference in this project. Simple implementation. All 2 external capacitors are required. efficiency is nearly 90%, optimized for doubler or inverting supply voltage, efficiency degrade for the output voltage, low cost, compact and low profile. It is a very low cost. You have to use a 10 to 15 diodes or 20 to 15 capacitor. So the price or the cost of this project is nearly 500 Indian rupees or under 500 Indian rupees if you want to make this project. And what is the simple block diagram of this project? You have to apply a AC supply, and that is a 230 volt 50 hertz AC supply, and that is given to the Cockroft Walton multiplier circuit, and then give up to a 1 kV output voltage, not up to a 1 kV output voltage, it give up to a 10 kV output voltage. Let's consider up to a 10 kV because 1 kV is not a high voltage supply. You can take a 10 kV as a high voltage DC at the output side. Let's further what actually modified a block diagram and what actual happen in the circuit. First of all, we have to apply a 230 volt 50 hertz supply to the circuit. Then it have a AC to AC converter, switching capacitor. This improve the voltage regulation. Then we give the supply to the positive Cockroft voltage multiplier, negative Cockroft voltage multiplier. So what this positive and negative Cockroft voltage multiplier does? Because there is a AC supply, so there is a positive cycle as well as negative cycle. So in both the cycle, at positive cycle also and the negative cycle also, we have to work the circuit. The circuit should be work on the both the cycle, so that the positive and negative two types of multiplier circuits are needed when we are talking about actual voltage multiplier circuit. Then that is given to the filter. Now these capacitor filters are much important because when we are trying to make a simulate this circuit, we get the waveform like this way. You get a DC voltage, but it is a ripple. There is a ripple in the DC voltage. You can see this is a ripple. This is a V ripple. This variation in the actually DC supply is like this way. This is a DC supply, but we cannot get a DC supply like this way that we get from the battery or any another DC source, but actually we get this type of waveform. So due to this we get a V ripple. You can see this is a VR is V ripple voltage. This is a voltage, that is a V ripple voltage, and we have to filter out this voltage. Otherwise we get this type of waveform at the output side. So that why we have to require the capacitor filter, and then we have to given to output or load, that is a nearly 10 kV. Here you have to consider 10 kV. So let's go further. What is the theoretical background? The most basic form of the Cockroft Walton voltage multiplier is a single stage voltage doubler circuit. So in figure, so first of all see single stage circuit. So this is a single stage circuit in which there is a two capacitors C1 and C2 are there, and two diodes are there, and the Vs is the supply voltage. This is a nearly 230 volt DC supply, AC supply, sorry, not a DC, 230 volt AC 50 hertz that we get at our home or that we get from the grid. So let's understand what is a theoretical background tells us. When the source is forward bias is on and the capacitor C1 gets charged to its peak voltage Vm. So let's consider what happened here. Diode when negative peak, it means that how AC voltage are there. First let's this way, at this it is a positive waveform, it is a negative waveform. So for negative waveform this is a positive and this is a negative. At this condition this is a positive, at lower terminal is positive, upper terminal is negative. So how the current flow? So you can say this is a forward bias because this is a positive, so it is a forward bias. So supply is the current is flow like this way. You can see this way the current is flow during this negative cycle. So during the negative cycle the capacitor is charged through positive polarity here and negative polarity here. So after this again the positive cycles are come. You can say this is again positive cycle come. So during this again positive cycle the polarity is changed from plus minus plus change to plus minus. So according at this position your capacitor is already charged with the voltage Vs, or you can say Vm, maximum voltage Vm. So according to at this condition what you get at this condition, your diode D1 is reverse bias because it is a negative is given to this terminal. So diode is reverse bias, so no current flow through this way. Now the current due to this way, plus minus, minus plus minus plus. So according to simple phenomena, there is a two battery and that is connected in the minus plus manner. So you have to add the voltage of this two battery. Now if it is a 2 volt and this battery is also 2 volt, so according to this way we have get a 4 volt. So here you can say this is also Vm and this is also Vm. So the polarity is minus plus minus plus. According to this phenomena we get 4 volt. So according to this phenomena we get 2 Vm. So this 2 Vm voltage come across the capacitor C2. So this thing is try to explain in this circuit diagram or in this theoretical background. When the source voltage is Vm, C1 gets charged to its maximum voltage Vm. In first condition, C1 is charged maximum voltage Vm. Now let's talk further. When using ideal diode, there will be a no voltage difference across the capacitor C2, and so there will be a no store charge in capacitor C2. On the positive cycle, now we are concentrate on the positive cycle. It means this cycle, positive cycle, this cycle. We have first we have understand this cycle and then we have understand this cycle. So now what happen in the positive cycle? On the positive half cycle, the peak voltage from the source is now in series with the voltage differential capacitor C1, so they get added. So what happened here, that I have already explained, these two things are come in series. The supply voltage, the supply as well as capacitor, both are come in series like this way. So the voltage potential is added and we get 2 Vm across the capacitor C2. So they get added or they added together. So diode E1 is now reverse bias with the voltage difference of the twice of the magnitude and the peak source voltage. So diode E1 is reverse bias. You can see I have already explained during this positive cycle, diode E1 is reverse bias because the positive terminal and the negative terminal are this way. The negative is given to this PN junction. This is a positive, this is a negative, is PN. So you have to apply this way to conduct the diode. The polarity of the voltage should be this way to conduct the diode, but during the positive half cycle the polarity is inverse, so this diode is not working. The diode D2 and the capacitor C2 work to reduce the ripple voltage in the output waveform. So what is the application of D2 and C2? The application of D2 and C2 are to reduce the ripple. I have already explained what is a ripple. This is a ripple, and by using a proper value of C2 and D2 we can reduce the ripple like this way. You get this waveform like this way. There is a less ripple in the output voltage, but there is a ripple. You cannot completely remove the ripple from the output voltage. There is some value of ripple in the output voltage. Ideally this create a voltage differential across the capacitor C2 equal to a twice magnitude of the peak voltage source. This theoretical assume that ideal diode and that the capacitor charge nearly instantaneously. In reality it will take several cycles for charge C2 to reach 2 Vm. It means in this condition we are talking about instantaneous condition, but actually there is some time, constant of the capacitor to charge the value of 2 Vm. In actual condition the capacitor cannot charge instantaneously to 2 Vm. It will take some time to charge. So now go further. So this is a basic voltage doubler simulation that I done in the MATLAB. So if you want this simulation file I will share this also. So I have explained already what happened in this is the same circuit. You can say the supply voltage, capacitors, diodes and are connected in same manner in this circuit, and we can check or we will check the voltage at the C2, it is a double or not, it become a double or not. So you can see that the supply is 230 volt 50 hertz. This is a supply, that is a 230 volt 50 hertz, that is a given to the circuit, and we will check the output at the capacitor C2. So you can say nearly what is a 230 into 2, 230 into 2 we get 460 volt. So you can say that nearly 458, let me zoom it, you can see nearly 458 is our output, and you can say that our circuit is working properly. So now if you want this simulation file, let me show in the MATLAB also. This is the file. I will share this file. You can get this file from the description box. So when I run this circuit, let it compile. It will take some time to run. It is now if you want check the voltage, you can say that our output is nearly 458 volt. So if you want to check a ripple voltage, so this is a ripple. It is a very less. You can see the 458.37 and 458.38. So ripple is very less, and you get a DC supply at the output side. It means voltage doubler circuit. You can say that there is a ripple. You can say this is a ripple in the supply. This is how you get, but it is a very less. You can say 458.38, 450. It is 0.01 volt ripple in the circuit. But this is why the ripple is less in this circuit. First of all, you have to think about this, because only a one doubler circuit are there. But if you increase the number of stage, or if you make a ladder circuit, there is a number of diodes and number of capacitors are connected in the circuit. That may increase the ripple in the output voltage and may reduce the voltage regulation also. So now what is the further? I will share the simulation file if you want, and that you get from the description box. Now let's start once again. In theory, more stage can be added to create a voltage tripler, voltage quadrupler, etc. In practical, however, it is not recommended to go beyond 12 stage. It means what these things tells us. This is a one stage. Only one stage is there. If you add extra this stage, you can say extra same circuit you have to connect across this, or across this diode, or across this capacitor. You get voltage doubler circuit. And again, if you add, you get voltage tripler circuit. So up to 12. If you increase more than 12, it will cause very less voltage regulation, or not a proper output voltage. There are a number of ripple or high ripple in the output. That things we will also see. So now adding more stage not only slow the charge time, because if the stages are more, capacitors are more, and it will take more time to charge, but it also reduce the voltage regulation by increase the ripple, increase the number of stage, increase the output DC voltage, but is also increase more losses, resulting less overall power transfer capability to the load, and this problem will be examined in the next section. So the Cockroft Walton voltage multiplier design is ideal because it relies only on the passive component. What is the passive component? The resistors, capacitors, inductors are passive component, and this design eliminates the need for the active switching component commonly seen in the rectifier and the booster circuit. Thus, it is necessary for Cockroft Walton voltage multiplier to use only a passive component. A Cockroft Walton design allows the input signal to act as a power supply to the entire circuit. So let's go further. This is a basic rating of the component, in which we have used 230 volt 50 Hz supply. The diode is simple that we use in the rectifier 1 and 4007, but if you want high voltage, you have to use a high voltage power electronics or power diode for the considering the high voltage, like 50 kV or 100 kV according to that. What is a capacitor? 1 millifarad, 10 millifarad, 1 microfarad, 100 microfarad, and this is a AC to AC converter IC for the improving the voltage regulation. So this is a circuit diagram that I have done in the Proteus. So if you want this diagram or if you want this circuit, I will share this circuit in description box. But do not rely on this Proteus circuit, because if I use one on another version of the Proteus, so it might possible this circuit is not working on your Proteus software. So don't rely on this circuit, rely on the or focus on the MATLAB circuit. This is the main MATLAB circuit in which I will share this circuit. You get this circuit from the description box. This is the main circuit. You have to focus on this circuit. So you can see this is a one stage of voltage doubler circuit. At this stage you get double, at this stage you get triple voltage. This is a 4 times voltage, 5 times, 6 times, 7 times, 8 times, 9 times and 10 times. So I have used 10 ladders network. So if you apply 230 volt here, you will get nearly 460 volt here, and so on. But it is not possible. There is some losses in the. So if you theoretically, if you think I have used a 10 ladder network, so I have to get voltage 230 into 10, because 10 ladder network are there. So 230 into 10, what I get 2300 volt at the output. But you cannot get this voltage. You get nearly 1.7 kV at the output. So let's understand the further. So this is the when zoom in, if I zoom in this part, you will get this part. If I zoom in this part, you will get this part, and if I zoom in this bottom part, you will get this part. Okay, I have not shown it. So you can see this is the main circuit. If you want to see this circuit, let me open the MATLAB circuit, MATLAB software. This is the main circuit. You can see this. You get this circuit. This is the main circuit that I simulate in the MATLAB software. Let me show you what is the supply voltage. Is a 230 volt 50 hertz, and when I simulate, you can say that the reading are changed accordingly. You can say we get nearly 396 volt. 396 volt at first stage. At second stage it is a 723 volt. At third stage we get nearly 985.5. At fourth stage it is a nearly 1191 volt. So according to this we get different waveform, and at final stage we get nearly 1721. So let me see you the waveform in the so you can see I have already seen the circuit in the MATLAB. Now if I apply 230 volt 50 hertz supply, so I get a nearly at first stage is a 396 volt, at second stage is a 724 volt. So this is a waveform at the first stage. So there is a ripple in the circuit. Sorry, you can see the ripple in the circuit. So if I double click on scope 4, I got this type of waveform. This is a main circuit. You can say this is a first stage, and we get 396 volt at display. And now check the waveform. You can say the waveform is like this way. So if I zoom in, so you can say that nearly 400 volt, this line in between the ripple, it is our waveform. So this is the waveform that we get at the scope 1. There is some ripple. So what is a ripple? What is the value of ripple? So if I check a value of ripple, this is a nearly 415. So 415 minus 375. So I get 40 volt. 40 volt is nearly ripple in the first stage. So at second stage, what is our voltage? 724 volt. So you can say there is a ripple in this circuit also, and nearly 720. So if you check ripple in this 723. So if you want to check ripple, then it is a nearly 750 at upper side and 680 at bottom side. So you can say it is a 70 to 80 volt ripple in the second stage. So as you can say, the in first stage the ripple is 40, as second stage is ripple is double directly 80. So that's why ripple is important in the this type of circuit, and the final output is our 1721. So you can say this is our final output. This is a DC, this is not a sinusoidal voltage. You can say it is a nearly zero, but the variation in the voltage, let me go to the PPT. So you can say that our voltage is in between this line is our DC voltage, and that is why the display is directly showing the voltage 398 nearly, because it is not showing the ripple, it is in between this ripple. So this is the voltage as the first stage. Now at second stage we get nearly 700, but there is a ripple. This is not a sinusoidal waveform. You can say it is a positive cycle, it is a positive. We are get this type of waveform, and this is a ripple. That's why we have to use a filter for this circuit. This is a 10th stage. At last stage we get 1.7 kV DC voltage. So, and there is some ripple on this circuit also. So this is our MATLAB simulation. If you want this file, you get from the description box. Now this is the I have used IC 7660 for voltage regulator IC, and this is the output of that IC. So this is the main our circuit, that is the main circuit that I have shown. This is the main circuit, and the result table for that circuit is this. You can say at first stage we get 396 volt, at second stage we get 723 volt, third stage we get 985 volt, and at last stage we get 1.7 kV or 1721 volt, and this is a DC volt with ripple voltage or with ripple. This is a DC voltage that we get at the output side, but there is a ripple, that's why we get this type of waveform. So when the stages are increased, output is also increased. You can say here as the stage is increased, this is the number of stage. As stage are increased, output is also increased. That is seen in the MATLAB, or according to that we get a nearly linear circuit. On x-axis it is a stage of multiplier, 1 stage, 2 stage, 3 stage, and output in kV. So according to this our output is also increased. Mathematical modeling, in which VD is a diode voltage 0.7 volt, VC is a capacitor voltage, VS is a supply voltage, VB is a drop in the diode, N is a number of stage. So V output is Vmax into number of stage. So if I use 230, then the output is 2.3 kV, but what we get nearly 1.7 kV due to some drop and due to ripple. And all capacitors are equal, that we have assumed. The capacitor that I use for making the circuit in simulation, this all the capacitor that I use, it's same. So what is C1, C2, C3 is equal to C, and this is the formula for that. And this is a total ripple voltage in this delta V, or the ripple. What is the delta V? This is the ripple that we get. This is the delta V. It is a ripple voltage. IL is a load current, F is a supply frequency, C is a equal capacitor in the stage, and N is the number of stages. So according to this formula we can count the ripple voltage, and this is a voltage drop formula. I hope you understand this video. This is the reference, and this is the books for the reference. And what is the conclusion of this project? We can conclude that by using a modified circuit, component required is less compared to the simple one, and it's provide doubler amplification than older one. So you can see that it is a less cost of this project, because there is no transformer is used. We can directly increase our voltage by using simple diodes and capacitor. We can analyze that how the output voltage change by changing the capacitor's value, as we seen in the result table. So thanks for watching this video. If you have still any query, just comment it, I will definitely reply. And if you want all the simulation file, this PPT, then MATLAB simulation file, Proteus simulation file, this PPT, then report, then all the things you will get in the description box. And again, thanks for watching this video.